Good afternoon, ladies and gentlemen. Under Vigyan Sarvatra Pujyate, which has been celebrated at 75 locations simultaneously, today is the third in the lecture series, and this lecture is being simultaneously live telecast to all the 75 locations. Today we have with us Dr. Tessy Thomas, Dr. Sridevi Annapurna, he is the Director CFTI, and we also have Dr. Kinkini Dasgupta Mishra, who is the Principal Investigator for the entire Vigyan Sarvatra Pujyate. Today's lecture is given by Dr. Tessy Thomas. Let me introduce her. She is a distinguished scientist and the first women scientist ever who headed a national mission for missiles. She is in fact known as Missile Woman. And the program developed by her for a long-range missile is used in Agni. Can we have a big round of applause for her, please? She is presently Director General of Aeronautical System and the former Project Director for Agni 4 missiles in Defense Research and Development Organization. She obtained her BTech in Electrical Engineering from Calicut University, ME in Guided Missiles from Institute of Armament Technology, now it's known as Defense Institute of Advanced Technology, and she did PhD in Missile Guidance from Jawaharlal University, Technical University, Hyderabad. Dr. Tessy Thomas is recipient of many prestigious awards, including Lal Bahadur Shastri National Award for Excellence in Public Administration, Academics and Management, 2012, DRDO Agni Award for Excellence, then Distinguished Women Scientist Award in 2016, and many more. We are all waiting eagerly to listen from you. It's a privilege to have a Missile woman within us, and not only us, I think 75 locations all over the country are eagerly waiting to listen from you. Ma'am, the stage is all yours. We'll listen from that side. Yeah? Thank you.
Very good afternoon to all of you. I'm really happy to be here, part of Vigyan Prasar, where they are celebrating the Vigyan Sarvatra Pujyate, Festival of Scope for All. I'm really privileged to be part of this science festival. It's happening all across our country, all through the nation, at 75 locations. We are in 2022 and come far ahead with respect to the science and technology development. Education is the prime factor what leads or takes us to the development of the nation with respect to economic growth or scientific growth, and a nation's prosperity or development is judged by the factor of our capability in science and technology. Keeping this in mind, today we have many initiatives taken by the government to enhance our scientific capabilities in the country. And today the theme of my talk is on inventions, innovations of Swadeshi science and technology. So if we look back, way back in 1960s, we used to see a revolutionized change with respect to the science and technology, that we first talked about the Akashavani, where we had the technology development and then came on to the television broadcast and computer systems. Like that, the technology started enhancement. Then in between we had a industrial green revolution with respect to the agriculture science, where we could get into the high yield crops. That's again a science part of from that field. Then came the industrial part, where it was 1980s, wherein the steel industries came into, and then industrial approach towards development of steam engines and systems like that. And we saw the first communication satellites, like remote sensing satellites, getting launched by the ISRO, Department of Space. The Aryabhatta was the first one, 1975, followed by Rohini rockets. So like that, the technology enhancements. Today when we talk about ISRO, the space science, has gone into achievements of the order of developing indigenous cryogenic engine for long duration flights, for a long distance travel, space travel. Then we have the missions like Chandrayaan, Mangalyaan, and today we are working on human in space, the Gaganyaan system. So the science has advanced its own way, and having satellite launch vehicles like PSLV and GSLV. Then all type of satellite communication requirements, INSAT, GSAT, education sat. So a follow-up of technology, we were with the analog radio waves. So we are trying to establish, and world across is talking about 6G. That's again based on a point-to-point wireless network, wherein which both radio waves and fiber optic waves are combined. So that is the level of technology enhancements happening in that side of the communication technologies. When we look at DRDO, where from I'm coming, where we have the defense technologies, we have different type of capabilities. As the history goes, the starting of aerospace, it's depicted in Ramayana and Mahabharata. Weapons like Mariga, Sushka, Brahmastra, Sammohanastra, and even the wall panels, paintings of Egypt depicts the picture of airplane, UAVs, unmanned type of pictures are there. So that all, today we talk about drones, unmanned systems. But that is how, if you look at the technology, then our early man, javelins, arrow, bow and arrows were used for fighting. The battle of Tilpu Sultan's time, the battle of Pullur and Gundur, battle of Gundur, were depicting pictures of using chemical rockets. So these are all the development was there with respect to science and technology way from years and decades. Now today when we talk about modern weapons or systems, defense systems, we talk about the starting from the V2 rocket, the first rocket system. With the development of navigation and guidance, we talk about highly accurate and pinpointing systems. And coming to the DRDO, we have developed technologies for the missile as well as electronic warfare, wherein which the capability with radar systems, and DRDO has put India in the top of the first 5 to 6 countries which has these capabilities. We have established capability in strategic, multi-role capability, anti-tank systems, as I said, radar and electronic warfare, fighter aircrafts, advanced early warning and control systems. So there are different areas. Now coming to the missiles, there are again two categories: the tactical missiles and the strategic missiles. Tactical missiles are short range missiles which have the capability to strike in short range from 300 meters to say up to less than 300 kilometers, where again based on the role of the missile, again it is categorized surface to surface, surface to air. It can be launched from surface. An example is the Akash class of systems, where we can target an incoming aircraft, anything which is airborne and coming within, can strike systems from a target of 300 meters to close to 100 kilometers. Then we have air-to-air missile, that's the Astra class of missiles, a faster system, where we have the capability of striking or intercepting a missile or a aircraft which is beyond visual range, that is close more than 100 kilometers. It's again based on the guidance, homing guidance, either the IR homing or the RF seeker. So dual mode different missiles has been categorized. Then we have the anti-tank missiles, starting from the indigenous development of Arjun class of systems. We have multiple variants with as on today the lightweight composite battle tank has also been developed. Then we have the missiles to fire against the tanks, that is again the Nag, Helena, and different versions of Sant. Different versions of missiles have come up. They all come under that tactical missiles, very short range, high fast dynamics, and the principle is working on homing or a seeker based guidance to the terminal phase. Then we have the surface to surface missile, the Prithvi class, the first of its ballistic range. From 40 kilometers to 350 kilometers, the range capability has been established with different platforms, from launching from land as well as from sea-based ship, as well as ship-based launches for the Prithvi class. Then comes the category of cruise missiles. When we say cruise missiles, the word itself means that cruising at a particular altitude. When this cruise missiles requirement is such that when they cruise for a longer duration, we have capabilities established up to 1000 kilometers. And if it is flying at a higher altitude, it can be seen by the enemy radars. So we need to fly at a lower altitude, and we have demonstrated subsonic cruise in the Nirbhay class of missiles with a range capability up to 1000 kilometers and flying lower than the tree top, that is lower than 100 meters, and DRDO has established first of its kind in the world that we have gone and flown at 5-meter altitude. So that low we can fly this class of systems. Capability has been established. Then we have a joint venture of BrahMos with the Russian. So that system we have proven the capability from 300 kilometers to 1000 kilometers in different platforms, ship launched, air launched, and land. All capabilities has been established, and it was first of its kind, again technology wise, first in the world to establish supersonic cruise missiles. So that again flying at lower altitude, coming down to up to 15 meters, and against a ship, against an aircraft, and against land attacks. So that was the capability established with the BrahMos class of missiles. Then we see in TV serials like in Ramayana and Mahabharata, two arrows comes and strikes. And that type of a concept, like missile against missile, anti-ballistic missile defense. So that is technology also were indigenously developed, and India is the only country which could demonstrate successful flights. So it's a big achievement as far as our country is concerned with a technology milestone, and we were successful in all our attempts, and that too we have demonstrated the capability in striking the missiles at exo-atmospheric as well as endo-atmospheric. When I say exo-atmospheric, it's above the atmosphere, an active atmosphere of intersecting a missile above 50 kilometer altitude. And exo-atmospheric between 10-15 kilometers to 30 kilometers capability. So that type of quick reaction systems were being developed as part of our tactical and systems, surface to surface. Then we had, I'll come to the strategic towards my end of my talk. Then we had radar systems capability, like locating radars for electronic warfare systems, which helps in the ground systems to locate a target, the radar capability for surveillance, tracking, and pinpointing or homing on to the targets. All capabilities has been established. Means we have an indigenous capability, we don't have to depend on any other source to have these technologies developed. Then coming to the fighter aircrafts, you all would have heard about Tejas, LCA Tejas and its variants. A fighter aircraft with chord redundant control capabilities, fly-by-wire methods, composite structure, weight reduction because of the airframe structure was by more than 30 to 40%, and a capability. Today, the LCA variants have picked on the systems like airborne electronically scanned array, ASS aperture, synthetic aperture radar capability. With that, country has a fighter aircraft which is world class. I don't think in this class of fighter aircraft anybody has established come to this class of technology. So that's why today you hear in industrial exhibitions and all, other countries are looking at our products to buy. So that level the technologies has been developed, and indigenous capability built over a period of time, wherein electronic countermeasures, the fighter aircraft can carry a wide range of tactical missiles, PGMs, bombs, all categories of weapons can be carried by that fighter aircraft LCA Tejas. And now we are getting into the variants of it, the advanced composite compact aircraft, which again one step ahead in the technology, one generation. When we call it in generations of aircraft development, LCA comes under the 4+ generation. The 5th generation or 5th generation plus is the AMCA, the advanced medium compact aircraft. So wherein which we built in not only the technology advancements in electronics, avionics, and bring in the structure again more lightweight, and having a capability of all the systems what I said, along with is the stealth. Stealth is that while the fighter aircraft is flying with all antenna and radiating elements, still we can have the stealth so others cannot detect. So the capability of developing those stealth materials with meta materials, again smart materials and meta materials, it's a technology by itself, so that a negative refractive index, so the light, whatever radiation falls in it, it will not reflect, it gets contained within the structure, and we provide a stealth to the system. So such technologies has been thought about building into the future fighter aircrafts. Then we look at the anti-tank. I said different versions have already been established. Then we had the airborne early warning and control systems, where airborne surveillance, tracking and reconnaissance can be done, where we call it as the eye in the sky, where the system can have a search or surveillance almost 400 kilometers away. So this being within the territorial and then look at things what is happening. So image exploitation, even a scooter movement, all can be tracked by this class of systems. So it has been widely used, by operationalized, and it's under use. So these technologies, again indigenously developed. Aircraft while flying, it has the capability to identify friend or foe, whether the incoming aircraft is a friendly aircraft, our own aircraft, or a enemy aircraft. All this technologies is possible by that class of systems. Then comes the strategic capability, long range nuclear capable systems, the Agni class of systems. The development of Agni 2 was initiated in the beginning, wherein which we first started with the technology demonstrator, where we didn't have this capability at all within the country. When we started way back in 1980s, it's a total technology denial regime was there, and we won't even get, in the name of Agni, nothing can be purchased, nothing can be procured. So we had to work and develop the systems from the very scratch, be it the materials, what we were using for the rocket motor casings. We started with the metallic rocket motor casings, 15 CDS steel alloy. Then for the first Agni 2, then we developed Agni 1. Metallic casing was used. And in Agni 3, better strength wise and some weight reductions in miraging steel. It's a high strength material, because when moving from Agni 1 and 2 to Agni 3, there is a quantum jump in the thrust and the rocket motor sizing. Agni 1 and 2 had a 1 meter dia rocket motor, which used to take us to Agni 1 had a range capability of 300 kilometers to 700 kilometers. Agni 2, the strike capability was between 800 kilometers to 2000 kilometers, and Agni 3 from 1500 to 3000 kilometers. So technology enhancements happened, and first technology demonstrator we used had a liquid propulsion system. Rocket motor was liquid, because that was the technology existing. That is the same technology ISRO was using for the rocket launching of the satellite systems. So launch vehicles had that liquid propulsion technology, wherein which it is more easy to control, like or terminate whenever we want. The fuel or the oxidizer can be stopped, so the combustion can be stopped, and you can terminate. When we look at it, it's very highly complex to carry on with liquid systems, the bulky, and technology wise handling at the use of field worthiness, it was very difficult. And lot of being liquid system, lot of control valves and actuator systems and all. Altogether it was a complex system for a field worthy operations. So we were looked upon development of solid rocket motor rockets, because it has to be compact in a compact size, but the energy requirement can be multifold. That was the requirement of the systems. That's how Agni 2, Agni 1, 2 and 3 were developed with that technology. And working with the solid rocket motor, again the technology is, once it's start burning, how to terminate? It's like burning from one end to the other. So the total energy has to be consumed, it will burn once the rocket is ignited. And that is where I was asked to design on the guidance law, wherein which we can terminate or we can change the path of the trajectory or optimum trajectory shaping and on board. So that's where I started working on the guidance scheme, where what I said, the Agni, all the Agni missiles has a range capability in a wide band. That is Agni 5 when we talk 3000 kilometers to 5000 kilometers. So the shorter range to the minimum range to the maximum range from one single mission. To have that, we have to onboard, because of this class of systems, what you need to give us the input is only the launch point coordinates, where I am standing, the geographical data of latitude, longitude and height of the launch place to the target point. That is target point, latitude, longitude and height. That's the only information required to the missile as inputs. It onboard computer does all the computation and capabilities, and it's simple. When we say the guidance takes, if it is a minimum range, you will have a lofted trajectory, it will go higher the altitude and comes back to the shorter range, and the longer distance it will have a shallow path, it will take a longer path and reach at a wider range. So that is the fundamental if you say that guidance has to work. We started with, when you look at the avionics side, at the start of the Agni we used 8086 based systems, where the computational speed was very less, and today we could talk about 400 megahertz speed of computation, and that is on power PCs and system on chip. So that is the way the technology has developed, computational capabilities has come. So when we look at Agni 3 with a launch mass of 50 ton, it was taking us, with all our technology, was taking us to only up to 3000 kilometers. When we look at the world across, they talk about this 50 ton launch mass systems going beyond 3000 kilometers, 3500, 2600, like that, and all numbers were heard. That is where again I was given the opportunity to work. I must call myself as fortunate to work on this class of systems, where I was asked to see the world class, what is the technology gap we are having. So one thing was on the system, overall mass of the system was so high, and there only we were asked to look into the next level of technology for the composite technology, that is replacing metallic structures with composite structures. To develop composite structures, we have to look for carbon fiber, which was also not available in the country. So we had to start with our CSIR lab, NAL, started taking the development of composite carbon fiber, and then the technology has today matured to high level of requirements and strengths. So we could develop the composite rocket motor technology, rocket motor casing technology, and prove its worth for this rockets to hold the propellants and take it. So that was established, and then overall from top to bottom of the missile has been re-looked and re-engineered, and an optimal configuration, we can say. A world class, first of its kind in the world, we can say, when Agni 4 was developed, where we had a stage of composite rocket motor, and with our total mass, it has come down less than half the weight of Agni 3, Agni 4 weighs around 22 ton, and the capability for strike from 1500 to 4000 kilometers has been established. So that is another milestone achievements. Agni per se, when it takes off, then came the Agni 5, where we had 2 stages of composite rocket motors, and with 50 ton we could achieve a capability up to 5000 kilometers. So that gives us a 3-stage guidance, 3-stage rockets, where it has to integrately perform. And in these class of systems, an error in velocity 1 meter will give you a distance of 5 kilometer error. So we cannot afford to have these class of systems in the navigation. Again, we had to go from a mechanical navigation system, DTG based gyros and accelerometers, to MEMS based, RLG based, and higher accuracy has come with the systems. And the impact accuracies, when the missile travels from this point to 5000 kilometers, and it has a capability of all azimuth, all Agnis has all azimuth, that means it can be launched 0 to 360 degrees anywhere, and goes and strikes with an accuracy less than, in single digits in meters. So that is the potential of such class of systems. One more important technology was on the reentry vehicle structure. So it goes high in the altitude. Some of the systems climbs up to 1000 kilometer altitude and then comes back with the speed. So where it is going and coming back, re-entering with a very high velocity, more than 20 times the speed of sound. So it has almost 4 to 5 kilometer per second. That is the velocity with which it is re-entering back to the atmosphere. So a lot of kinetic heating happens to the surface, and the re-entry vehicle structure, which contains the electronics, avionics for further activities for weapon release and onboard instructions. So these systems, the composite technology is again, the structure thickness is of the order of 20 to 25 mm. Mm is like this. So that is the thickness, and outside the structure, outer layer, the structure faces a temperature of the order of more than 3000 to 4000 degrees centigrade. And unimaginable. We didn't have facilities to test the structural capability. Thermostructural test also we couldn't do to that level, because that is the type of temperature environment or the thermal environment it is coming. And inside, within the 25 mm inside, temperature should not be more than 50 to 60 or 70 degrees, because all our navigation and onboard computers, the electronics inside cannot function beyond that temperature. To develop a structure of that nature for the re-entry, we had to again depend on the composite technology, wherein the carbon phenolic as the top layer, which gives the thermal protection, which can withstand the 3000 and 4000 degrees centigrade, and with the property of so-called the ablation techniques. So it will become red hot, it will remain, and it doesn't propagate, it gets charred but doesn't propagate the temperature into its inner layers. Inner layer, we have a structural layer, the carbon epoxy, which can withstand the strength of very high G, which is coming at this velocity, and the maneuvering, the G is of the order of 30 to 50 G, which is too high for the structure. And that is the technology. With the development of that reentry vehicle structure, with the carbon nose tip and carbon phenolic and carbon epoxy structure combined thickness is 25 mm. So I myself have witnessed more than 50 launches of Agni different versions, and the technologies has been established, and the systems is any variant. In this category, we can make any systems. Similar is the same concept from underwater submarine launch systems. Same capabilities has been established. With all these technologies, on 27th March 2019, we have demonstrated the capability for an anti-satellite strike. So with this class of rocket motors, we can take it to any destination, either travel all over and come back, re-enter back to atmosphere and strike surface targets, or it can strike satellites, in any enemy satellites in space. So that is how the technology demonstration has happened. It has been demonstrated. Then comes the Agni also is hypersonic, but moving at hypersonic with the rocket propulsion. Then is the newer systems is talking about hypersonic cruise as well as hypersonic capability to fly at 30 kilometer altitude, which is a very high dense atmosphere, where we'll have lot of kinetic heating, because when the missiles or the missiles are traveling at a speed more than Mach 5 and 6, that's the hypersonic, where we use the scramjet engine, the supersonic combustion. We take the air intake from the free flow and then burn the combustion at a supersonic combustion, and that is used for propelling the missile. So that technology demonstration also we have done successfully on 7th September 2020. Capability of flying it for 20 seconds was demonstrated. It's first of its kind. And when we look at the hypersonic cruise applications, it has very multiple applications in long range air defense, tourism and travel. We talk about if we board a flight from India to US, it used to take 24 hours. Now systems have improved, the airplanes have a better capability, and within 18 hours we are reaching. But this hypersonic technology can shorten the travel time between the two continents within less than 2 to 3 hours. So that is the type of capability what we are working for the future. So the technology capability has been demonstrated. So that is one area, and we keep hearing of space tourism, people going to space and coming. Industrialists abroad have already started taking people for the space tour. So that all becomes more possible with this technology getting developed. These are, again, as I said, one set of technologies already which we have already developed. Then today is the new era. Way back in 2006 BC, we used to talk about a pathfinder or a compass, which was the only tool which would have given us the geographical location. Today from that, the technology has moved on to GPS based systems, satellite and GPS based navigations. So that the technology has moved along way back from there. And today we talk about the emerging technology areas. Since our computation capabilities has increased multifold, we can think about systems with artificial intelligence, robotics. Robotics is again technology enhancements which has happened with the avionics, the electrical, electronics, mechanical, actuation systems, hydraulic systems capability, all has given us the technological advance to look into robotic systems, artificial intelligence based, in communication, quantum computing, cognitive technology, asymmetric technology. You imagine anything, it is possible. Today the world is all looking at digitization, automation, where we can talk in the manufacturing sector, the 3D printing, additive manufacturing. We all have heard about Internet of Things, cloud computing. All the computational capabilities have come so much, so data can be transferred in seconds all across, or in nanoseconds. So that is the way the technology has come and moving on with. And the young generations who are all there in school and colleges who are learning technologies, you are at a more beneficial area. When we all had to read the books to get the knowledge. Today knowledge is all around you. You need to tap the opportunity to learn. And there is much talk on Internet of Behavior, IOB. So that is the way the things have started, so that the technology, when you look at a person, you can recognize what is his thinking in his mind. That is the way the technology has improved. We have also established technologies for face recognition. Even the person comes in a disguise with all totally different facial features. Still we can put a mask, whatever it is, still you can identify the person. Not only as a single, but in a crowd, we can identify. So that is the level of image processing and artificial intelligence or deep learning has made us and taken us to this path of technology. And from today, if you talk from that end of the technology to unmanned systems, everywhere we talk about drones. Starting from our wedding function, we'll see the drones operating, to a military application, a long range endurance missions, where the UAVs goes, unmanned aerial vehicles goes and drops weapons. That type of facilities technology has developed to take on such class of systems. So that is the way the technology has moved. And first invention is something like way back in 3500 BC. You know the potter wheel. Potter makes the pot, still rolls, and the technology even today that potter wheel is still rolling. But that was the first invention in a scientific invention, if you take, that was way back in 3500 BC. But still, if you look at potter, making pots is still based on the same technology. So it's still rolling, and the technologies keeps coming, and lot of enhancements will happen. And we as a country, India, looks for the development of science and technology in a big way, and government initiatives, and our honorable Prime Minister has visioned India having Atmanirbhar Bharat, self-reliance. So looking forward for all the technologies to be developed indigenously, and that capability has to come from all of us who are all listening and to this talk. So you are the ones who have to change the nation into that. We'll be in the back seat. You are the runners to make this self-reliance and Atmanirbhar Bharat a long way. Thank you, and Jai Hind. Some questions there.
Thank you, Dr. Tessy Thomas. You can sit, we will take questions. Yeah. Thank you very much. Being a missile woman, it was really interesting the way you have taken us the mesmerizing world of the missiles, ballistic missiles, cruise missiles, and then also surface-to-surface missiles. There is extrothermal and endo-atmospheric missiles. It was a nice storytelling format. She said that the strategic requirement. In a nice storytelling format, she took us to this, the tantalizing journey of Agni from 1 to 2, 2 to 3, and 3 to 4. And let us also understand, she is the person who actually was an integral part of that guided missile part, which is the Agni is using. So it was really, for us, we are very fortunate to, listen to a lecture from such a person who herself has played a very, very crucial role in development of all these missiles. She also talked about the futures. When we were talking about 1.52 knots, that is 2 times of the speed of sound, she talked about 20 knots while re-entering vehicles. So that kind of R&D research is happening at her institute. It's really something we should all cherish about. Can we take a very quick questions because we have from 4. Let us also know that there's a Antarctica live, and all of you would be very glad to know you will be able to ask questions here. 4 to 5, be here with us. But before that, I would like to take few questions and only restrict here only 1 or 2 questions. Is there any? If not, okay, we may take questions from others and we'll send it to you, ma'am. May I invite on stage Dr. Sridevi Annapurna, please, and we'll take this opportunity to hear for at least a two minutes talk from you. Your vision for this program and as well as your guidance. Please come and talk for 2 minutes, please.
A very good evening to all present. What a fascinating talk it was, madam. In fact, it took me back to the days of, we were seeing this TV series of Ramayana and Mahabharata, and we were seeing one arrow becomes 10 and, flying through the air and all that. Probably in the coming days, that will become a reality too. I am not a missile person, I am a food person. I have been working on food. So I see a lot of children over here. 2 things I would like to say. I'm sure most of you are students. So if you are students of science especially, one of the most important things that you need to have is communication. The reason is, if it is not the person who makes the first discovery who gets the credit. We all know that. Many of us have read how J.C. Bose worked on radio waves, but somebody else got the patent and the credit for it. The person who is able to convince the world the first, they get the credit. So science communication, as is the theme, is of extremely very important that we should learn how to communicate with our peers, how to convince the world, how to talk with all people, be them children, be they our peers, be they our elders, doesn't matter, be they scientists or not. We should have this ability to communicate. Since, the second point I would like to say is, even as before we are born, our health has already been decided by the health of our mothers. So it is extremely important that we take good nutrition. This pandemic has shown us that it is very, very important that the role that diet plays in our health. And it is not the medicine that is going to cure, but the food that we eat. So please take care of your health. and definitely you will be more alert, you will be able to study better, and you will be able to make the future of our nation, which is the greatest of all nations in this world. Jai Hind.
We have with us Director Dr. Nakul Parasar. I request Dr. Parasar to come and say a few things for the budding scientists here and all the students here. Yeah.
Well, good afternoon. I know we have another program lined up, so I will not take much of your time. So it's time for us to, have a few more good things added to this program. I have with me a very well-known author, a scientist from JNU called Dr. Sabarish, who has written a book on history of science, and I'll request respected Dr. Tessy Thomas ma'am and Dr. Annapurna ma'am to please unveil these two books for this young writer. And this book is available at Garuda Prakashan in the bookstall. So this is a book launch at this place. So please give a big round of applause for Sabarish. And I'll request Sabarish to autograph it for Dr. Tessy Thomas ma'am. And if you could do that, that would be nice. And it's a wonderful book, so I will request please take a chance to see this. Even it's a little expensive, but we have arranged for special discount for students over here. So if you really want to buy it, you can buy it. I'll request Manisha to please.
Now may I request Dr. Parasar to felicitate Dr. Thomas.
Yeah.
Now Director Nakul Parasar is felicitating Dr. Annapurna Sridevi, Director CRTI.
Ma'am, thank you so much for being with us. We truly honor, and you've taken time to come all the way from Mysore and Bangalore. It's a privilege to have honored you. Thank you so much, ma'am. Thank you. Thank you.